So continuing our lesson on sections 1.2 and 1.3 in your notes, this is page 9. Remember, we've been talking about equations and expressions all the way back up here. Let me show you really quick. We talked about the difference between an expression and an equation. We said that an expression has variables and numbers, but an equation is different because it has an equal sign. We said that with expressions you simplify, and with equations you solve. So we looked at in our last lesson how to simplify some things using PEMDAS, simplifying numbers. We also looked at evaluating expressions, that is when you substitute a number and then simplify. And then we did more simplifying with expressions, this time combining like terms. So we're continuing that to say, okay, what about equations? How do we solve equations? So we need to just make sure that we remember our PEMDAS still from before, parentheses, exponents, multiplication, division, addition, and subtraction. And I want you to remember when we talk about inverses, an inverse operation is something that undoes another operation. So we talk about things like multiplication and division being inverses because they undo each other. We talk about addition and subtraction undoing each other. We're also going to talk a lot about solution points or solutions. A solution or a solution point is simply a value that makes the equation true. To solve something means to find all solution points for an equation. This could be done algebraically. This could be done numerically. Or it could be done graphically. Remember those 4 ways we talked about? Algebraic, numeric, graphical? The only one is verbal, and we could describe it verbally, but solving it algebraically with the equation, numerically with numbers, graphically with a graph. So we are going to focus on the algebraic and the graphically for right now. Solve algebraically and graph the solutions. Think back to Algebra 1. We're solving for x, so we want to get all the x's together and move everything else to the other side. I have a 7x and a 2x. I need those on the same side. So to move the 2x over, I need to do the opposite of 2x. The opposite of positive 2x is to subtract 2x from both sides. So 7x minus 2x is 5x plus 3 equals negative 12. And now I need to move that 3 over, get him out of the way. So we'll subtract 3 from both sides. Move my work up here. Positive 3 and negative 3 are opposites or inverses, so those will cancel. We'll have 5x equals negative 12 minus 3 is negative 15. I have 5 times x. How do I undo multiplication? I use division, so we'll divide. So we have x equals negative divided by a positive will be negative. 15 divided by 5 is 3. So algebraically, x should equal negative 3. On our number line, this means that we put a dot. Yeah, can you see that? A dot on the x equals negative 3. That's it. That's our solution. That's how we graph it. Let's practice some more together. This one, we do have n's on both sides, but we also have this 6 we need to take care of. 2 choices. We could distribute the 6 right away, or we could divide by the 6, since that would undo the 6, and divide this side by 6. Both ways are good. Let's do the distribution way first. You might like this way best. 6 times n, 6n. 6 times negative 4 equals 3n. Now I still need to put all my n's on one side, so I'm going to do the opposite of 3n. So I have 6n minus 3n is positive 3n minus 24 equals 0. And then let's move the 24 over. Whoops, there should not be an equal sign right there. Okay. And then move my work up. These will cancel. So I have 3n equals 24. 3 times n, so I'll undo the times with division. N equals 24 divided by 3 is 8. That's one way you could have solved this, distributing. The other way you could have solved this is to say, right off the bat, you're going to divide by 6, and maybe you'll like this way better. Divide by 6, divide by 6. N minus 4 equals 3 and 6 would be 1/2 n. I need all my n's on one side of the equation, so I will subtract a 1/2 n, subtract a 1/2 n. My work up. So 1n minus a 1/2 n is 1/2 n minus 4 equals 0, because those would have canceled. Move my 4 over. Whoops, I'm sorry. Move my 4 over. Cancels. So I have 1/2 n equals 4. Now we have to get rid of the 1/2 here. Again, 1/2 times n. The other thing we could say is that it's 1n divided by 2. What's the opposite of division? Multiplication. Or remember what we learned about reciprocals, that any number times 1 over that number should cancel. So times this side by 2, times this side by 2. 2 times 1/2 cancels. 4 times 2 is 8. So we still get n is 8 both ways. Either method you choose, totally fine. That's still our solution, and we're still going to graph 8 on our number line. Just one dot, right at 8. That's all it needs. And another example. For this one here, we could do either way, but because we have a number in front of both parentheses, I think it will be easiest for us to do the distribution method we did up here. So we'll distribute the 4. We get 4m plus 36 equals negative 3m. Negative times a negative is a positive, 15. Put all the m's on one side. Opposite, plus 3m. So we get 7m plus 36 equals 15. Undo the positive 36, so the opposite of 36, the inverse here. 7m equals, and 15 minus 36 is negative 21. Seven times m, so let's undo the times with division. Negative 3. And we graph that right here on our number line. Single dot at negative 3. Okay, so those are some examples for how you would solve an equation and then graph the answers. The other thing you can do for solving is that sometimes, take a look at your next page, sometimes you have equations where it's all variables. Look at these, there's no numbers in these. That's possible. Sometimes it's a formula. This one here, that's not necessarily a formula I know of, but we could use a formula like the circumference of a circle, the area of a square, and we'll see some of those. But when you work with variables, there's something really important we have to remember. Remember that when you have variables, you might sometimes get a fraction. You can never have a denominator of 0 in a fraction, right? So to have something like 5 over 0, bad, cannot do it. Which also means you cannot have x over 0, cannot do it. Also means you cannot have x over m, and let's say on the side someone says, oh yeah, let m be 0, cannot do it. So because we cannot have a denominator of 0 ever, so at any time, you can never have that. Because of that, we have what are called restrictions. This means it's a value or values which would ever cause a denominator to be 0. So we say some values are off limits for a variable. Let me give you an example. Let's say you have 10 over m minus 3. What value would cause the entire denominator to be 0? Remember we said we don't want the denominator to ever equal 0. That'd be bad. What value would cause this to be? Well, if m was ever a 3, 3 minus 3 would be 0. That'd be bad. So we'd say restrict, we would say m cannot equal 3. It's not allowed. If it equaled 3, the denominator would be 0. That's what we mean by a restriction or an off limits. So we'll keep an eye out for that as we do our work to make sure that the denominator never reaches 0. Solve for the variable specified and state all restrictions. Solve for x. X is right here. This is what we want, just this little guy. So that means I don't want, did it show up? There we go. I don't want that b there anymore. I want to move him over. How is the b connected? He's connected by multiplication, and the inverse of multiplication is division. So I will divide by b and divide by b. So now we have x equals c divided by b. X is solved, yay. But look, here's the denominator. We cannot have that be 0, so we'll state on the side, b cannot be 0. That is our restriction to go along with our answer. It is part of your answer. You need both pieces when you're solving with variables like this. Let's look at the next one together. We're still solving for x. This time we have a times x and a b times x. We need to get the x by itself. How do we do that? Well, think back to when we just did distributing on our last page. We're going to do the opposite. We're going to pull it out. We're going to factor out the x. Factor out the x. X times a would give you ax, plus x times b would give you bx. So it's just going backwards from distribution, factoring. Still equals c. X is connected by multiplication. I don't want this piece anymore, so I'm going to divide by this entire piece. So that piece cancels. So now I say that x equals c divided by a plus b. Again, my denominator cannot equal 0. So just the same way up here we said b cannot equal 0, we'll say a plus b cannot equal 0. That's our restriction. Okay. Part of your homework is for you to complete this page, page 10, and also to complete page 11. So I'm going to give you the answers to parts C and D, but I need you to do the work for them to get those finished up. And if you have questions, you can ask me in class or after class. So the answer for this one, solving for A, would be A equals x times the quantity b minus 10. And also we would say that x cannot be 0. That would be our restriction. So you need to show me the work to get to that point. And then the answer for this one, solving for h, is that h equals 2a divided by b, and b cannot equal 0. That's your answer for that one. Okay? Let's look at an example together on our next page. These ones are some application questions, pulling in some geometry and some other formulas. Part A we're going to do together. The sides of a rectangular field are in the ratio 3 to 2. What is the length of each side if the perimeter of the rectangle is 110 miles? Always draw a picture for these. It helps us see it. So we have a rectangular field, and I'm going to put a chicken in my field because I can. All right, well, kind of a chicken. Grouchy chicken, I don't know. But there he is. Are in a ratio of 3 to 2. Meaning if this side is 3 something units long, and in math, how do we say something? We say something with a variable. So 3, let's say x's long. We don't know if it's whatever, but 3 somethings long. Then this side must be 2 somethings long. Then it tells us that the perimeter, and remember perimeter is all the way around the edges of something. So let's fill in all the edges since we need those. If this is 3 x's, this is 3 x's, and 2 x's, all the way around is 110 miles. So we could say 110 must be equal to 3 somethings plus 2 somethings these ones, plus another 3 somethings, and finally the last 2 somethings. We now have an equation. We have some variables set equal to a value. We can solve for the somethings. And if we solve for the somethings, we could say whatever 3 somethings is, and that would tell us the lengths of our sides. So combine like terms. 3 plus 2, 5, plus another 5 is 10. So 110 equals 10x. Undo the 10. 110 divided by 10 is 11. Now careful, it's not asking for what is the length of x, it says what's the length of the sides. Remember, it's 3 times the somethings and 2 times the somethings. So 3 times the somethings would be 33, and that's not right either. It needs something else. 33 miles. 33 miles. And this one will be 2 times the somethings, which is 22 miles, are the lengths of your sides. Now, I'm going to let you work on part B on your own or with a partner, again, as part of homework. That needs to be filled in for me. The answer for this one, what is the length of the longest side? The answer for this one should be 12.5 centimeters. Is the length of your longest side. Okay, but you need to draw a picture, set up your equation, and show me the work of how you got there. This next one, okay, is again more practice for you. You're going to solve for C in this formula. So your answer here, which you should show me the work for, should have that's your answer. You need to show me the work of how you got there. And then when you plug in for part D here, your answer for this one should be, let's see, 26.1 repeating degrees Celsius. And then on a number line, I need you to fill that one in for me too. How would you graph this on a number line? Okay? So those need to be finished up for your homework. But that is how we finish our lesson for equations. So we've seen a couple different things. We saw how do you solve using algebra by undoing things to get your solution all by itself. How do you graph that solution point on the number line? And then we also looked at how do you solve equations that are only made up of variables, and how you have some values that are off limits or are restricted because they would cause your denominator to be 0. We never want that.